So now let's go through the main function line by line. So first what we do is in this line is to initiate a writer object. So this is to write the records. Now this is what is used to create this test and train records. So this is a writer, and then we read the annotation file, which is the CSV file which we talked about. So this specific file, that's where what we read it, and we know that it's in the args annotate file, the arguments annotate file. So here arguments annotate file. So this is the argument. So from the arguments we read the CSV file, and then what we do is we set the path as the complete path to the image directory. So image directory is again another argument. This is the argument. So this is where the path is set to the image directory, which is this folder, the complete folder to the test or the train images. So that's this path, and then what we do is once that path is set, we list down every files or the path to every files within that specific folder. So here image files consist of, say for example, if you're going to process the train record or the train images, it lists down all these 18 or all the 16 image paths. That is what contains in the image files. Now what we do is we iterate through each of those images, because we have to write the specifics of each of those images into the TF record. So we iterate through each of those image files, and the first thing is we extract the name of that file. So here the name of that file is that pothole1 JPG. So and it's there in the complete path. Let me just show you here. So let's see. This is our path. This is our complete path, and then let's put this here, and then you're splitting with the backslash, and we are taking the last one, -1. So we are taking this pothole1.jpg. that's what comes here as f name, and then we look into the annotate records. Now annotate records are those annotation file, so here this annotate records is the annotation file which the annotation file, that CSV file which we read. So looking at that annotation file, looking at those specific annotation file name is equal to where the file name is equal to f name. So f name is this JPG. So let's look at this. So if this is the file name, so we are looking at the specific file name. So first let's say we are processing this pothole1.jpg. so it takes all the records which are related to this. So it will be a bunch of these records in data frame format, which will be taken, or which will be stored in this annotate records. And then what we do is we pass these annotate records and this image file, that specific image file, into the create TF example. So this is the specific function which is used to extract this. Let's go through each of those functions. So we pass the path and the annotation record here. And then what we do is we read the image. We read the image as a byte file, encoded byte thingy. So it's another format of reading the image from the path. So now this image contains those the byte information. So we extract the width and height from the image size. From the image size we get the width and height, and it will be equal to this width and height. Okay, so we extract the width and height, and we extract the file name also. So we have got the file name, which is we have got the file name. So we go to extract the file name. So we have the path, which is the path which we have got, the full path which we have got. Again we split the path. So we have those we split the path with this, and then take the last one, which will be the file name. So which will be whatever that file name here, say pothole1 or pothole2, etc. that will be the file name, and the format will be the JPG. So all of files are JPG mat. So we make the image format as JPG. Then we get some list or initialize some list to store many of our information. So this is our xmin, xmax and ymin, ymax information which we have. in the folder. So these information, the bounding box information, to store these lists are to store those bounding box informations, and also these are to, one is the class text. Now for example, the class text is like potholes, and the classes are those IDs which are related to that potholes, and this is part of that dictionary which we created. So label map dictionary is where there's a mapping between the class name and the ID. So that also we are storing. So what we do is we go through each of those annotation records. So this annotation records, I said, would be specific to, like this, would be specific to a lot of records, would be specific to a specific file name. So if it is pothole 1 JPG, and assume that it has only 4 or 5 of these records, so it'll go through each of those records and then append the xmin, xmax, ymin, ymax from each of those rows, okay, into these lists, and then we normalize it by dividing it with the width and the height, and then we append the class text, which is the row class, which is this class. See, this is one row of that annotate record, and then we take the class of it, which is a text, and we get the ID of that. So from the label map dictionary for that particular class. So if the class is a pothole, row class will give you the text file of the and we like potholes, and we get the ID. So that is stored. And then finally, this TF example is the object which we finally write for each of those examples. So this has to be in this specific format. So these are the features which you have. So image height will be the, there is a specific function called dataset util, which is part of the object, which is part of the API utils. So with that, we store the height, width, file name, all the file names, encoded JPEG, which we earlier loaded. So encoded JPEG as the JPEG file for this. Then image format, what is the image format, which is the JPEG file. Then all the other information, xmin, xmax, and the text and the label. So all these information which we so far extracted are stored as a TF example. Okay, so that and what is returned is the TF example. So this is for one record, one of this record, one of the file, and how many ever bounding boxes are there. So each of them will have all those TF examples written. Okay, so we get the TF example here, and that is written as a string into the TF records. Okay, so this is where we get this TF records written. So now that's all about this particular function. So, and now once you run this, now let's see how do we run that. Let's look at that specific example of how do we run that. So you run that in your terminal. So let's copy this complete path. It's a pretty long path. So let's copy that, and then just give me a second. So it's a pretty long path which we have. So let's copy all those things and then see what do we have here. So here, let's copy it here. So here first is Python, then generate tfrecord.py is our file here, and then first we give the input image path, which is train. Then we give the annotation file CSV file path, and then we give the path to the text file. Then we give and we give the output path, which is a TF record, train record or test record path. So that's all those all the command line prompt which we use to execute this. So once we execute this, now we will find those records, the train records, and then later we have to execute the same thing for the test one also. So only difference is now let's look at this So these are based on the parameters here. So -I is this one, image directory. Then so you can say when we executing it for the train, we give the path for the train, okay, and if it is for the test, then you will see that it's for the test file. I've got that specific path here. So you give the path to the test file. The same kind of command prompt. First we'll have to execute for the train and then for the test. Only difference is we'll have to change the paths which is required based on the parameters, and then what do we have? So -a is this, the annotation file. That will be the same for both these paths. -l is the labels path. That will also remain the same. There is no change for that because there is only one labels file. And -o will change because -o is for train and test. It will be different. So here till the annotation file, annotation path would be the same. For the test, it will be the test.record, like what we see here. See here, it's test.record. So once we execute this, we'll see that one by one. First we execute the train records and the test records. So after that, you will find these records getting formed in your annotation folder. Now these are the steps which are required, or the basic data formats which are required to start our training process. Next, what we will see is we'll see our actual training process, which you would have seen in the YOLO example in post 5. So those of you who have not seen that YOLO, how we train a YOLO model from scratch, YOLO object detector, YOLO V5 object detector from scratch, please refer to the post 5, which is again in this descriptions, or it will be there as part of the blog. So you will see that in TensorFlow Object Detection API is also very similar. We will be using some of the native files which comes through the Object Detection API, and we will be using that for the training purpose, and it will be all based on the on our command line prompt for even both the training, and you will see that the same thing happening in the case of inference also. So let's get into the training process now in the next video.